Hi everyone, my name is Deiwin, or Deiwins in Latvian. The joke works better in Estonian. And I'm going to talk about safe and fast delivery, essentially about the deploys. So for starters, a little bit about myself. I may look young, but I've been building things like this for at least 7 years now. Right now I work at SaleMove, and I build things like the one I'm going to talk about. On a more personal note, one of my hobbies is lifting other people. Alright, so let's get to the topic. This graph is essentially what I'm going to talk about today. What you see here is number of deploys that SaleMove has made to production over the last year. No need to look into the specifics right now, but you can clearly see that there's some change since April of this year. And what I'm going to talk about is why there's a change there, and what did we do to make the change, and how did it go, and so on. Alright, so before April, what we did in SaleMove in terms of delivering changes to production is twice a week we would take all the changes that were made up to that point that weren't already in production. We'd take them, we'd push them to a production-like environment, we'd run some manual tests on them, we would let it bake there for a day, and then the next day we would push it to production. And we would do that twice a week. Why did we do it this way? We had been, sometimes before that we deployed more frequently, sometimes we deployed less frequently. But when we started deploying more frequently, our stability suffered a bit. Sometimes we deployed something and things broke. And the important thing to know here about SaleMove is that we're a business-to-business company. We sell to big enterprises like banks and insurance companies. And SaleMove, I'm from Estonia, and the SaleMove technical side, all of it is in Estonia, but we sell everything in US. Our headquarters in US, is in US, and these big companies I talk about, these are like Fortune 500 banks. And you can imagine that I'm here to tell you that twice a week is slow. Deploying twice a week is slow. But these banks, they deploy twice a year, and I think that's progress. Alright, so eventually, after some trying, we reached the point where we deployed twice a week, and everything was more or less stable, and developers were okay with it. But they weren't happy. Why? Mostly because of a few specific things. One of the things is that if you deploy regularly on a schedule and not too often, then the time from when you make the changes and when they're in production is long. This is an issue for a couple of reasons, one of which is SaleMove, there's a practice that the task isn't finished until you have validated it in production. Let's say you need to change what a button does. It's not enough that you write the code. You have to go to production, click that button, and see that it does what you expect it to do. Or somebody else has to do it. But until that point, the task isn't finished. So if the time difference between you making the code changes and clicking that button is 2 days, then you might have, and it doesn't work, then you might have forgotten about all the details and everything. So if you want to go back and work on it further, it's an issue. It's more of an issue if the change actually breaks something. Let's say you change the button, but for some reason the entire production goes down. If you made the change 2 days ago, you're less likely to know what the cause of that downtime is when compared to making that change half an hour ago. And in addition, we would deploy a bunch of changes together, and that further makes it harder to understand if there's an issue, what was the issue. So essentially the problem is context switching, and in case of an issue it's hard to understand what the cause is. There's also some things about zero downtime deployments. A quick question to the audience, I don't know. Sorry. Let's say you have service A and service B, and service A goes to service B to get some information, and you want to change the interface and the service A that uses that interface. So you want to change the interface in the client, and you want to do it cleanly, so that you clean up all the leftovers and whatever, and you want to do it with zero downtime. Who knows how many deploys that takes? Anybody?
4.
It's 3. Did you show 3?
I also showed 3. Yeah, my finger.
You're correct.
Like this, yeah.
So yeah, you know, there's a couple of ways about it, but you could add like the new interface, keep the old one in one deploy. In the next deploy, you change the client to use the new interface, and in the third deploy, you delete the old interface. You know, 3 deploys. But if 3 deploys means 2.5 weeks or 1.5 weeks, then are you going to make refactorings that take 1.5 weeks? Probably not. So there's a couple of issues with deploying that infrequently, and developers were not happy. But also we weren't able to just deploy more frequently because business wasn't comfortable enough changing in that direction. So I did some research. I did reading. You know, there's big companies, GitHub, Etsy, whatever. Everybody's writing, we deploy 100 times a day. It's all good. We never break. And if we break, we fix it in a minute. So I wanted us to get into that place. Luckily, I happened some time ago on this thing. Who here has seen State of DevOps reports? Few people. So, good people from Puppet and Dora, they've been doing yearly, they've been talking to companies, IT companies, and asking about their practices. And what they've done is they've clustered companies into 3 categories: high performance, medium performance, low performance. And performance here means essentially how much money you make. And they found year after year that there are some characteristics that high performers have that medium and low performers don't have. On here, I've taken an excerpt from the last year's report, and you can see that high performers on average deploy multiple times per day, and to get a completed version of some change from go complete to tested in production, it takes usually less than an hour. So we weren't there, and you know, all of you here are probably very smart. You know that correlation doesn't equal causation, but at least you could correlate so that you don't run against the trend. Here's the same data on a graph. The numbers are linear, so you can see that this difference is pretty drastic for number of deploys per year, and lead time, which is the time from go complete to tested in production. All right, so this data is really good because business people, they like numbers, and they more so they like numbers about money, and this is what the report is aimed at. It's aimed at you as a developer selling your ideals that you intuitively know that might be a better option, selling those to the management and to the executives. So if you don't take anything else from this talk, then you know, look at this report, and if you're unhappy with your DevOps practices at your workplace, push this in front of your managers and see what happens. Alright, here's some code. It's very small, you don't really need to read this. I just read the instructions for this meetup, and it said if you have code, show code. But essentially this is the core of the thing I'm going to talk about today. What you need to know about this is that we decided after some prototyping and discussing with the team, we decided to take an approach that I think GitHub is most known for advocating, which is called branch deploys. And here's how it looks. You make some changes to the code. You open a pull request. Everybody knows what a pull request is? Okay. You make a pull request. You ask your teammate to review it. Your teammate says, there might be some back and forth, but at some point your teammate says, yeah, that's good. Your CI passes, your tests pass, your linter doesn't complain, so on. And usually, if you're familiar with GitHub, then what most projects do is that they merge the commit. But that's not what happens with a branch deploy. With branch deploy, you can see here that there's a check with something deployed in it, and it's required, which means you can't merge this PR yet. You have to do something. And in our case, what you have to do is you have to write bank deploy. Once you write that, a little while passes, and you get a notification, hey you, the changes you made were validated in acceptance, click here to proceed. If you click on that link, you're brought to Jenkins UI, and this here is a Jenkins pipeline. And if you just follow the instructions here, step by step, you'll go through the process of deploying this to production-like environment, testing it there, and then deploying it to production, validating that it works, and then, and only then, when you've deployed it to production and you've confirmed it works, the PR can be merged, and it will be merged automatically. So if this is familiar, might be to some of you, then GitHub advocates this as GitHub Flow. Although most GitHub users don't use GitHub Flow, it's nicely shown here on this picture. You create a branch, you work on the branch, you create a few commits, you open a pull request, you work with your teammates to make sure that it's actually what the team needs. You maybe add some more commits, and then you don't merge, but you deploy the thing. And this is taken from the GitHub website. And it can only be merged to master once it's verified in production. And this gives you the guarantee that everything that's in master actually works. CI is good. It makes sure that you don't merge something to master if the unit tests fail. But this is better because you don't merge anything to master unless it's verified that it actually works in production with real users' real data. Alright, so this is what we built. Remember this slide? High performers deploy multiple times per day, and lead time is less than 1 hour. These are our results. You've also seen this slide. This time let's look more closely at it. The white columns, they're deploy counts, aggregates, sums over 30-day periods, so months, and the thinner ones are weekly aggregates. The light colors are the process I mentioned, where we regularly take a bunch of things that have been changed, and we push them through a process and eventually into production. And the darker bars here, yeah, I call it orchestrated, the regular one. And the darker ones are branch deploys. We now average roughly, if you count that this was a vacation month, we do around 100 deploys a month compared to less than 20 earlier this year. And here's some numbers about timing. Usually a PR takes, this is less than half an hour, and in the worst case, also less than an hour. But there's some things here that are more than an hour, but this usually stems for the fact that you leave the PR or the change pending, you push it to some environments, but you don't finish the process for some reason. So these numbers were in this range. That doesn't make us a high performer, but
if I can ask a question.
Yes, sure.
In the previous slide, you showed that you do most of your stuff as branch deploys and that some still as orchestrated ones.
Yeah.
What is the stuff that requires orchestrated rollouts when you already have this branch deploy stuff?
All right. So how we migrated, and this is a good question because I haven't included this in this presentation, but it's important. Is how we migrated the two branch deployments. Is you can sort of see it here. We have a lot of services, or intents of services, and initially we started with just 3 services. We took first we started with something that wasn't mission critical. We tested, it works, it's nice. Then we took 3 of our core services. We put them on this system, tested this for a while, and then it was free reign for all the developers. If you work on a service and you don't like how slow it is, you can easily put it on the branch deployment system. So right now, I'd say more than half of the projects have moved over, but not all of them. So all of the old ones have to use the old system. And I'm going to get back to this later, but there's some reasons why we can't at the moment migrate some of the projects over.
Database related, most probably.
Actually, we recently moved the database things over as well, but this was a sort of a shortcut. We don't, I'll also mention this later, but with everything, rollbacks and everything is tested properly, but with databases we just don't do rollbacks, and but we still went with the branch deploy model because we found that we almost never do rollbacks.
You just pray.
Yeah, pretty much. And if something goes wrong, you roll forward. It's like an action move. Alright. But I've been talking about speed a lot. Taleb puts it nicely, talking about speed is meaningless unless you also talk about what I sort of alluded to earlier, if you don't talk about stability and safety. He goes on after this quote to say that what you need to talk about is effective speed, not nominal speed. So yeah, obviously if you drive 250 miles per hour in New York, you're going to crash into the first thing you see. Alright, so let's talk about safety a bit. You saw this in the walkthrough, everything that went through that we had in every safety guarantee that we had in the old system, CI checks, linters, code reviews, everything we still use. And I think that much is obvious. End-to-end tests, if before we had a huge suite of end-to-end tests, we run it highly parallelized, and it takes roughly half an hour to finish. And we run it every 2 hours. I mean, we still do, but we don't rely on it that much. And now what we do is we deploy or define these end-to-end tests per specific service. So only only the things that this service is responsible for, only these things will be tested. And this includes what we call acceptance testing. In our terminology, this means testing through the UI. So we have fake browsers coming up, and then there's, by other I mean, you can test a web server without the UI. It's still an end-to-end test as the requests go through many services and so on. So these are tightly built into the deployment system. One more thing about acceptance tests is we have a special acceptance environment, which is different from our other environments in the sense that you can create random users and other entities in that system. So you can test almost every scenario. Unlike our production environment and some other production-like environments where you're not allowed to create fake data. You don't want to take test data on your production servers most of the time. Alright, so who here knows about Kubernetes? Show of hands, please. Okay, not too many people. Kubernetes is a container orchestration system. If I say environments, that's what I mean. In our case, an environment is a Kubernetes cluster. And with Kubernetes, you already out of box, you get some safety guarantees. But especially when we move to this branch deployment model, we have to carefully look at some of the things for every project. So I'll come back to the one-time despots, but the thing with Kubernetes and branch deploys is that if you're deploying more frequently, you're gonna have pods dying and coming up more frequently. And pod in this case is think of an instance of your service, runtime instance of your service. To deploy more frequently means you kill running instances more frequently and you spawn up new ones more frequently. That much is obvious. And to do that safely, you have to have two guarantees. One is that requests, for example, let's talk about web services. So web requests, they shouldn't go to a service that isn't ready to serve that request yet. If it hasn't put it up, it hasn't connected to the database, or it hasn't connected to, I don't know, whatever, it shouldn't receive a request because it will probably fail. And on the other hand, if the service is dying, it got a kill signal, it shouldn't receive any more requests, and it should finish processing the requests that it received before. This way you can guarantee that almost all of the requests go to a healthy pod. And how you do that in Kubernetes is you need to look at the readiness and liveness probes. If you're interested, you can just Google those things. And graceful termination is the other hand of this equation. And you can Google pre-stop, Kubernetes pre-stop for that. Alright, rolling updates. Kubernetes has rolling updates built in. So if you have a readiness probe, this means that Kubernetes doesn't consider your service instance healthy until a certain condition you give Kubernetes. So for example, if you have a /health endpoint, and until that endpoint responds with a 200, the instance isn't healthy. And you can do whatever computations in that service to figure out if it's healthy or not. So let's say you deploy to acceptance, everything's good. You deploy to another production-like or up to a production-like environment, everything's good. And something very specific to the production environment isn't good. So you deploy to production, and the database URL is wrong for the service for whatever reason. If you define to readiness probe and the readiness or the health endpoint doesn't return 200 unless it has a database connection, Kubernetes will start the instance, but it will not send any requests to it until it thinks it's ready. And also, it will not continue with the updates. So rolling update means that, let's say you have 10 instances, you get a new version of the same service, you add one instance, you kill one old one, you add another instance, you kill the old one until all the instances are new. And you don't move forward with that process unless all the new instances are working properly. It just stays in that state. Alright, and another thing is one-time test pods. This is also something we baked into the process where you can, in the same environment, you can spawn up a process that just tests your thing, and it can use the internal APIs and everything. It doesn't have to go through the internet to reach your service, but it can use some internal things, and it runs in the same environment, in the same local network. Also in our process, we include manual validation. There's some things that are really hard to catch by machines. There's a lot of work in data mining and AI to avoid this, but as far as I can see, we're not even close. So for every project, there's a checklist that the developers of that project can define. And when the service is deployed to a production or a production-like environment, they have to go through the checklist to verify that it works in that environment. Usually, what I advocate to be on the checklist is a link to a dashboard and a simple check that, please make sure that the change you're actually deploying does the thing you want it to do. And the devil is in the details. What the dashboard is the most important part. You usually look at the things that indicate an issue. You look at error rates, you look at service saturation, traffic, so on. There's the Google SRE book has good stuff on this, on what to put on their dashboards, if you're interested. If the error rate is high, dashboard would be nice if it would have a link to the error logs and you can see what's happening and so on. For example, GitHub, who we got a lot of inspiration from, they have their own tools to correlate exceptions with deploys and easily show what's related to what and so on. But that's not built into the automatic deployment system, but that's for a human to look at. Alright, so you have all of these checks. And if any of these fail, let's say the automated tests fail, we roll everything back. Kubernetes fails to roll the chains out, it doesn't start properly, everything is automatically rolled back to the previous state. Or if you deploy the thing, automated tests say it's good, Kubernetes is fine with rolling it out, everything looks fine, but you see that the traffic drops to, 10%, and you didn't intend to drop to 10%, then you know that something's probably wrong, and without hesitation you click abort, and everything is rolled back. And this has worked. Now, as I said, business was hesitant about deploying things more frequently, moving faster, but with this for many months now. We're deploying more often. Our incident rate and essentially product stability. Our incident rate hasn't grown. I can't tell with absolute certainty. We don't have enough data that it's fallen, but it definitely hasn't grown. And the perceived stability from the business is also really good. So this has worked for us. A combination of all these safety guarantees. Any questions here this far? No?
Deployment settings for special environments.
So can you raise your hand right now? Sorry.
You have different environments. For different environments, you have different settings. No matter some connections to other systems, to databases, to whatever.
Yes.
Different amounts of connections, so like that. How this different different parameters for different environments where it's stored.
Do you mean for the tests or?
For this automatic deployment, it should take those.
So this is. Are you familiar with Kubernetes at all? Alright, so essentially this is currently for us, it's outside of the deployment process because we only handle deployment in service resources, Kubernetes resources, those are specific things. But these configurations are stored in a config map or a secret, which are also Kubernetes resources for those who don't know. But these are managed outside of this process, so manually essentially right now.
So do they just depend on, are they defined once per cluster, and then you just live your life with automatic deploys, or
Yeah,
script for it? Okay.
pretty much. And if you need to add something, you add it, but only then you make your code use it once it's there.
So it's still possible to define something in acceptance environment, Kubernetes cluster, test pass there, then deploy to master because you've forgotten to add that environment, that variable to production and have it fail there.
No, because you don't merge to master until you verify it in production.
Oh yeah, right, okay.
That's the biggest point essentially of the inference in place. All right. So this is essentially the overview. I'll also show the interface. So let's say you're a developer at SaleMove. You're working on a project, a service, and you want to use this thing instead of the burn process. Essentially, there's some things that are outside the scope that you have to do, some little things, but this is essentially what it boils down to. This is Ruby code, and it goes into your project's Jenkins file. Those who don't know, Jenkins file is essentially a CI process definition. It's in our case, it's imperative Ruby code, and this already, in our case, includes all your, running tests, building the project, building a Docker image, and so on. So what you do is, you call this function, you pass the image, press the project name. You define this running cube thing. You define the tests, what we call smoke tests. I don't know if you're familiar with the term. For every environment, this is run. So this running cube thing, this is what I mentioned before, the one-time test pods. So this is spawned in the same environment that the service was just deployed to, and you can run specific tests against that specific environment. But then I mentioned acceptance is special. You run some, tests in parallel so that it's fast, but only in acceptance. And then for a specific project, you define the checklist. As I mentioned, usually it's dashboard plus to make sure that the change actually works. And that's it. This is all you need to do. So, what next? there's a few, we haven't been doing this for a long time. There's a few things that we see that are issues or are going to be issues. One is lock contention. Right now, for every environment, only one deployment can happen at a time. This builds into the flaky tests. If you have multiple people deploying things simultaneously, you might get flakes like one affects the other and you don't know what's going on. And there's ways to work around this. I'm not going to go into this for now at the moment. Flaky tests. As I said, everything will be rolled back if anything fails at any point. So if you have flakes, if you can't trust your tests, if they sometimes fail, it's very frustrating because, try to deploy something, it fails, but it wasn't your fault. And you have to start all over. This can happen a lot. I don't know if you have process with testing through the UI, but it's not always reliable. So this is one of the things that we have continued to work on, but it's still sometimes a problem. And also device support. I mentioned that some of the projects we can't move over to this process yet. This is because we need to verify that things work on iOS, for example, or some actual devices. We don't have this support yet. We only run a Selenium cluster of Firefoxes and Chromes. Initially our checklists weren't 2 items, sometimes there were 9. But imagine going through 9 items or 3 environments for every change. It's a lot. You start ignoring actually looking at the things that you're supposed to look at, and you get fatigued and you start missing things. Branch deployment. Obviously, if you're going to deploy every change, a lot of companies actually don't do that. I personally talk to people from Netflix, Facebook, so on. That's not what companies usually do. But luckily, we're not the size of Facebook yet, so we have a chance of trying other things. Once, for example, lock contention starts to be an issue, or maybe some other things, maybe the checklist fatigue sets in too much, we might start, bundling for a certain service, bundling up the changes and only deploying once an hour if there's any changes, stuff like this. Better overview. Tooling is great, it works well. We don't have a good UI for it yet. It's hard to tell what's being deployed in the last day, for example. You essentially have to look at Jenkins or GitHub or Slack logs. So if you're on call and you wake up 4 AM and you know that this is obviously this service, it worked for a long time, doesn't work anymore. Obviously it was something that changed during the last day. You have to, it's hard to know what changed during the last day for a certain project and to roll that back. Ideally you would have like a UI, you see, go back 1 day, click a button, and you're back to that state. And also creating new clusters with the same states, stuff like this. Automatic canaries. Netflix has a really cool tool where you deploy canaries. Does everybody know what the canary is in this case? A few people, not everyone. Okay, so essentially you deploy a small subset of the service. So let's say you have 10 instances, you only deploy 1, or you send only 10% of your requests to the new version. If you think that this version works well, only then you increase the percentage, and finally, if you're happy, then you move everything over to the new version. Netflix has a cool tool that does this, automatically. They built in heuristics. It deploys to a certain percentage. It calculates sort of like the tool says, I'm this confident that this version is good, And if the confidence level is within the range, it increases the percentage until it's totally rolled out. We're not, that's a lot of work, and I don't think we'll get there in the near future. But canaries, as manual canaries, that you click a button to first put it to 10%, you click another button to put it to more people. We will probably have to support. And Project Bootstrap. So I mentioned that there are some specifics about Kubernetes that you need to know about and to handle well. And not every developer, if you're developing a web service, it's not useful to train every developer in that area. So it would be good to have those best practices encoded in like a project skeleton that you can easily duplicate and start from scratch from and add your features to it. So if you start adding new things, you already get the best deployment process and CI process out of the box without having to worry about it. These are the things that we, or mostly I, see that we're gonna have to work on in the future. Thank you.
Thank you for the talk. Does anyone have questions?
Are you planning on open sourcing any of this?
I predict that question. We've thought about it, but the thing is, it's very specific to our setup right now. So our specific setup of environments, we have acceptance, beta, multiple production environments, and they're all Kubernetes. I don't know how
Yeah,
I got
that doesn't
this.
seem very specific to you.
Well, maybe, but like that exact setup, yeah. I didn't see a good way to generalize this easily, so we haven't. We thought about open sourcing it just for the sake of open sourcing it, so that if you're building a similar thing, you can see how we've done it, learn from it. We might do this. I'm not sure if we'll support the generalized solution.
How many programmers are involved in this deployment process?
The tooling?
No. Building this deployment process, defining it, and for how many programmers are users of this process, and how many programmers are doing all this stuff, programming all those Ruby, scripting, all this. That's how many programmers are users of this process, and how many programmers are doing this deployment process.
Right. So I built this mostly alone. We have, let's say, 20 developers. Most of them are using it.
And how many of them understands how it works?
I gave the same presentation to them 2 days ago, so I hope they understand a bit.
I was curious, like, how do you test multiple branches of the same product at the same time? You do a lot of manual testing, I believe, so how do you organize this inside?
No, we don't actually, like any of the things that we branch deploy, we don't test manually. It's only like validation, verification. There's all the things that you can define as a test, those are automated. But yes, there is a question of multiple branches, and for testing, you can run back deploy, goes through the testing process, and you can do those concurrently, not in parallel. So, as I said, we lock the environments. So actually, only one change will be in the acceptance environment at a time. But you don't have to wait there to get to the acceptance environments. You can queue it up essentially. The thing is that if you, let's say, one project, 2 people have 2 changes in this project, both of them click deploy, both of them are tested. If one of those goes through the process of getting to production and getting merged, then the other one will fail and they'll have to start over, because this change no longer contains everything that's in master, and so we can't push that to production. And there's, I haven't thought of a good way to work around this issue, but at least you can do the testing part in or kind of concurrently. Does that answer your question?
Yeah.
How long is that pipeline? So much time it takes from starting pipeline until release?
No, it's too far. Alright, so these are our projects, top 5 and bottom 5. These are minutes that it takes from bank deploy to merge. So this pipeline leap is like a test thing that we use to test changes to the pipeline itself. That's why it's fast, it doesn't actually do much. But other things, they're slower. Let's say usually 20 to 40 minutes.
All right, thank you for the questions. If anyone has anything else they'd like to discuss, please approach Deiwin afterwards or during the break. Thank you very much for your talk. This is